Hello, this luckiest maths teacher in the world. We turn our attention now to applications of matrices, how we could use this in the real world. So firstly, I'm going to show you how this could be used in something like business. So yes, I'm going to give you an example involving cologne. So let's say a store sells 3 types of colognes, 3 brands, Creed, Tom Ford, Christian Dior, all wonderful brands. Now in the table, I've put how many of each they've sold each day. So this number means they've sold 4 Creeds on Monday, this number means they've sold 5 Tom Fords on Tuesday, etc. Now I'm going to show you how you would use matrices to calculate how much money the store has made each day. Now you're very intelligent people, so you're probably thinking, well, okay, this is pretty simple. I could just add up the number of Creeds, multiply by 70, because they made $70 profit per bottle. Do the same for Tom Ford, multiply by 55. Do the same for Christian Dior, multiply by 45. Now, of course, you could do that, and that'd be quick. But if you're running a business, and some of you are going to have very successful businesses, you might have heaps and heaps of different things that you sell. And in that case, you could use matrices, but in fact, you'd get a calculator to use, a computer to use matrices to calculate your takings. So these matrices, they're very, very useful at making calculations quicker. It's just that in the example I'm giving you, I want to keep it simple and not give you too many numbers so you can understand. And so it isn't necessarily a true reflection of how they are used in business, but if you had a big business, these types of calculations would be invaluable when you've got heaps and heaps of numbers. So let me show you how to use it. So firstly, I'm going to convert this table into a matrix. So basically, I'm going to write the table without any words. I'm just going to include the numbers. So the first row, 4, 2, 3, 0, 5, 1. As you can see, all I'm doing is copying the numbers. Now, what I can do is also set up another matrix, and that tells me the profit of each bottle. Now, because Creed was our first column here, and we do a cross by down and all that, when I go to do my profit matrix, I want the first entry to be Creed. So I need the $70 here because Tom Ford was my second column here. I want it to be the second row of my profit matrix here, 55, and I want Christian Dior third. So it's important we get things in the right order. Now what happens is, if I multiply this matrix by this matrix, so this one is of course a 4 by 3, this matrix is 3 by 1, my resulting matrix will be 4 by 1. So I put it up like this, 4 by 1, it'll have 1, 2, 3, 4 entries. Now, because of the way matrix multiplication works, this first number here is going to be 4 times 70 plus 2 times 55 plus 3 times 45. So what that means is it's going to tell me how much money I've made on Monday, because I've made $70 for each of the 4 Creed bottles I've sold. I made 55 for each of the Tom Ford bottles I sold, etc. So that's where matrices can make this really quickly, particularly if you're using a computer. So the entry that goes in here will be 4 times 70 plus 2 times 55 plus 3 by 45. And you can just put that on your calculator, you get 525. So this first number means I made $525 profit on Monday. Now, predictably, the second entry here is going to be the profit that you earned on Tuesday, because we're taking each element here, so we're pairing up the number of Creeds I sold with the profit per Creed, so 0 times 70 is 0. We're pairing up the number of Tom Fords I sold with the profit for each Tom Ford, so it'd be 5 times 55, and then 1 times 45 for the Christian Dior. So if you add all those up, 0 times 70 plus 5 times 55 plus 1 times 45, then you end up with 320, and that is how much money I made on Tuesday. Now I go and do the same thing, this row by this column, and if I multiply that, that will give me the amount of money made on Wednesday. So that's 630, and it turns out that the last entry is 670. So if you want, pause the video and make sure you get the same answer that I did. So that's a way that we can use matrices. It's a quicker calculation. I know doing it by hand, because matrices are still a bit new, I think it actually takes longer than if I just multiply it. If I just added all these up and multiplied them out, I said there were 14 creeds sold, times it by 70, whatever. But as I said, when you have more and more of these numbers, it becomes harder and harder to do by hand, and so we'd actually get a calculator to do it. So that is one application of matrices, taking tables of things and making calculations quicker. We're now going to look at another example of where we'd use matrices, networks. So please pause and copy down this example if you need. Okay, so I've just drawn a network diagram here, and you're probably thinking, what does this mean? Well, each of these ones here represents a state of being in something. Now, these could be used in heaps of different examples. They're actually, called Markov Chains. So you could use this, say, in finance when you're looking at the state of something, say the Australian dollar or something. They're used sometimes in business when you're doing a big project. One could be the first activity that needs to be completed, two could be the second activity that needs to be completed, or something like that. Networks are used all over. This could even be a network of roads. We don't need to worry so much about what it represents. We just need to understand what it's saying. So this one is a state, could be a place, could be a task, whatever. So same with 2, 3, and 4. So there are 4 states here. Now what these arrows mean is a path from 1 to 2. So that means you can go directly from 1 to 2. So it could be a road that directly goes from 1 to 2. It could be that, it's a task and you need to do 1 and then you can do task 2 or whatever. So that's what the arrows mean, a path. So what we can do is we can draw up a matrix. I'm just going to call this matrix A. So what we'll do is we'll write all the states up here. And we'll put this into a 4x4 matrix. So what we do is we write the number of paths from one state to another. So from 1 to 1, there are no paths. There are no direct paths back to it. So we put a 0 there. From 1 to 2, there is one path. So we put a 1 there. From 1 to 3, there are no direct paths. And from 1 to 4, there are no direct paths. So there's a direct path from 4 to 1. But not from 1 to 4. Okay, so we can do the same for 2. So there are no paths from 2 to 1. There's one path from 2 to itself. There's 1 to 3, 1 to 4. And then we do the same for 3. There's only a path from 3 to 4. And then for 4, there's only a path to 1. Okay, so make sure we get this right. So the rows tell you where we start and the columns tell you where we end. So this entry here is from 1 to 3, not 3 to 1. So that's really easy. I mean, you can all count and you can tell how many paths there are. But what we can do with matrices is this helps us figure out subsequent events. This can tell us the number of two-step paths. So A squared tells us how many two-step paths, how many ways there are to get from, say, 1 to 3 in 2 steps. And again, this could be, roads. How do we get from road 1 to road 3 by going through another road? How many routes are there? Or whatever. So if we square this matrix, we can do the multiplication, A times by itself. So we end up getting this matrix. Now, I'm actually not showing you the calculations one by one because I've already gone through matrix multiplication in other videos. You can always ask me if you need any questions. So maybe you want to pause the video and see that if you square A, that you get this matrix here. Okay. So this is A squared. So this is the number of two-step paths. So again, I'll just put up the states 1, 2, 3, 4 just for your convenience. So this one here, number 0 there, means there are no two-step paths from 1 to 1. There is no way to get from 1 back to 1 in 2 steps. And we can see that from the diagram. We can go from 1 to 2, but there's no way to get back to 1 in one more step. So this number here, a 2, means there are 2 ways to get from 2 to 4 in 2 steps. So what we can do is we can go from 2 to 3 and then 3 to 4. That's one 2-step path. Or we can go 2 back to itself and then to 4. And that's a second. So that tells us there are 2 ways that we can go from 2 to 4 in 2 steps. And again, 2 and 4 could represent any states or whatever in so many different types of situations. So I'm just showing you how this works, and you will get questions about this. So this is how you do networks. This is how you form matrices. If I wanted to then calculate A cubed, I won't in this example, but that would tell us the number of 3-step paths, the number of ways you can get from one state to another in 3 steps. All right, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.